All right, so I was thinking that I would be one of many presentations today on assessment. So, but this is the last one before we sort of have a general discussion about it. So I'll probably put a few provocative statements in there, and you have to guess which ones I actually believe. So that's my get out if you don't like what I'm saying. This talk actually should have Laura as a co-author. I think she's going to. Well, she probably will interrupt throughout the talk, I expect.
Yes.
She's used to that, but we'll definitely have a main. Well, there's some slides at the end which I'll definitely leave to Laura. So I guess the idea here is that I'm not actually a total pessimist about what's happened during the pandemic in the teaching space. I mean, there's certainly a lot of things about online classes that are less than optimal, and some of that is just that we're not used to it and the technology is not so good. We haven't found the right way to do it yet, and the students were all forced to do it when they weren't ready, and we were forced to do it when we weren't ready. And the same with assessments. Some things perhaps are worse and some things are definitely better as a result of the changes we were sort of forced to make. So perhaps this story here is a little bit about a sort of positive, something that I see as positive coming out of the pandemic. I mean, the other thing about the pandemic just generally was that the rule book was thrown out. We were everyone was accepting of all sorts of crazy changes we would make in order to cope. And if you tried to do that in normal times, it would be a huge pushback. So let me, okay. So before I describe something about our exams, I better just sort of, I guess, set the context in which these exams are in first year maths at UNSW. And that's sort of quite important because if you just compared our exams to what they used to be or what they probably are at many other places, you would think, oh my God, that's crazy. That's just way over the top. But we've changed the assessment structure so that during the term, students get to sort of practice and repeat basic skills. That's the sort of focus of the assessment during the term. They get to see some more advanced things during the term, certainly in the lectures, and there are problems that they can work on. But the focus is on just sort of repeated practice. So they have weekly lessons that allow unlimited attempts with instant feedback. These are online. They have a couple of tests, which this is for most of it varies a little bit, but a couple of tests which allow unlimited practice on a test bank before the students take the test. So they should be getting, I mean, they can get full marks and they should be getting 80%. There is an assignment, they have an extended period to work on that. So, they can sort of polish it. During the term, they should be getting a high mark. We tell the students we expect at least 40 out of 50 in their pre-exam mark. If they're aiming to pass, that's 40 out of 50. In practice, 35 out of 50 is the sort of mark where the passing students, the ones who just scraped a pass, land. But we tell them 40 out of 50, and the average in the term is about 42 out of 50. So the exam is quite a different thing because it's adding onto something which is almost full marks. There are students who get 50 out of 50 and have passed the course before the exam, and there's even a course where the exam is less than 50% and they can pass. In fact, we insist they pass before they get to the exam. So the exam is sort of focused more on deeper understanding. There are still some basic questions in there, but essentially a pass is meant to be solid work on the basics during the term, and then sort of show up to the exam and do a bit. But there are students who pass who get 10 out of 60 in the exam, and that's not an indictment on our students. That's just that they have done all the work during the term, but they're not the sort of student who's going to be able to pull out something a bit more conceptual in the exam. And I mean, part of this is to do with UNSW's short terms. We have 10 weeks, and one of them is essentially a break. So there's 9 weeks of teaching, and that's really too short to absorb information and really start grappling with with it on a deeper level for most students. But there's a variety of students, and many students can do better than that and do. Okay, so credit distinction, high distinction is a pass plus the deeper understanding, I guess, is what I would say. Okay, so I think the future may be already here, and some things here are on this page. We have lots of questions, and I don't know if anyone recognizes what the chess buffs here. You know what that chess game is in the top right corner. This is a test, probably. I didn't. I just googled it, but this is the first time that someone know.
I know. Yeah.
So it's the first time that a computer, Deep Blue, beat a sort of a human Kasparov in a more than one game in a sort of multi-game tournament. So
don't ask me to tell you the whole story, but anyway.
Well, that can be part of the discussion later.
Yep.
And anyway, the point is that that computers, we're quite used to the idea that computers do things that were thought to be just the province of humans in the past, and we sort of expect more of that. We're very used to smartphones just knowing everything that we might want in advance and expect it. I mean, I turn off the personal assistant, but most people just let it rule their lives. We've been here before. The picture, I don't know, I got this picture from Wikipedia. I did a lot of research on Wikipedia before this talk. The picture in the bottom left corner is apparently the leader of the Luddites, and they were of course very concerned that they would there was all the training they'd had to do various tasks would be completely taken over by machines, and they wanted to destroy the machines. I'm sure there's a much more complex story there too, but the world didn't end, although you need to be careful about how machines are used. And of course, we here all probably appreciate maths in ways that the students don't always, and I guess the maths as art, we sort of see truth and beauty and such like in maths, but of course maths is still very useful too. Is there any sort of practical need for hand calculations anymore? I guess I would say there certainly is. I mean, you really need to do some things yourself in slow, clunky ways to sort of build up your mental model. It's my new buzzword is going to be mental model, after Merrin's talk yesterday, and so I think there still is, but it's not the same. It doesn't have the same emphasis that it previously would have had. And how will students use mathematics? Well, they're actually probably not going to do any hand calculations in the future, most of them. They will just be using software packages. Even if they're doing calculations, they will just be commanding software packages to do those calculations. So this is, I think, something we need to really think about. What do we want students to know? A lot of students learn that x squared becomes 2x. And some of them might remember that's happens when there's calculus around, and some of them probably forget that, or that's the only thing they remember, but they don't know what it means. So this was another I guess topic yesterday that cropped up. For many students, I think no matter what we would like, the assessment is the syllabus. And as you can see on the right there, there's a picture of me demonstrating to the first year team at UNSW how to engage students in something which non-accessible material, right? And well, it's hard, So I think probably we just need to accept this and try to make the assessment more reflective of what we want, and things that the students will, both things that we want and the students want. But we don't want to go too far down the what students want, because we often see, actually Joshua was reminding me, well, he mentioned a yep, x squared can go to something else. Yep. That's very confusing. I know. Joshua, I think, came up with was looking through the course surveys, and what was? Oh dear. Can you hear that? There's a fire alarm building just here. You don't have to leave the building. Yes, where was I? Yes, Joshua was looking through the student survey comments and reminded me of another one that I can't remember what his comment was, but it reminded me of a student in our first year maths course, and he was in the comment. He said, "I'm an engineering student, and I think it would be I don't understand why you waste our time with matrices and Gaussian elimination. We're never going to use that again." So I always keep that in mind when I read that we should listen to students and what they want. We should listen to students and what they want, but we need to also explain to them what they should want. But students focus on assessment. That's undeniable. And exams, if we keep the same structure, I mean, our final exam is at the end after all the classes finish, and it's the sort of grand finale. It's the pinnacle. It should sort of have that sort of quality. It shouldn't just be perhaps more of the same, in my opinion. Well, that's the way I'd like it to be. And perhaps the most important point for me is that exams become past exams, and we sort of keep them, and there should be students really do look to them as perhaps not a thing of beauty, but something of interest, and we sort of keep them in a, well, not just in a cupboard, we put them in a display case, and we let students marvel at them, and the students practice on them. The students really do learn from past exams. The pandemic, probably I don't need to tell anyone what happened there. The pandemic hit us, and we suddenly moved online. Everything moved online, and assessments moved online. And I know some places, there was online proctoring, but at UNSW not, and many other places also not. Our exams were unsupervised, open book, open internet. Clearly there was collaboration, even if we said there shouldn't be, and contract cheating. Software, online calculators, etc., means you can't ask questions like the one down the bottom there. So I don't know whether that the picture there is, not quite as diverse as it should be. I think there's perhaps it's saying that mostly boys cheat, but I'm not sure. Actually, that's not true. I have many counterexamples to that, but so we know that the students are going to be collaborating, and we try to make that as ineffective as possible. Perhaps some people embrace that. It's a pretty radical view, and let the students collaborate. I'm not that sure I want to do that, but we have all of these problems, and we have to think about how we can do it. Some of these problems are sort of easier to deal with than others, and I think the unsupervised open book, open internet is easy to deal with, in the sense, well, not the unsupervised, but open book, open internet is easy to deal with. You just say, go for it. You can do what you like. Of course, there was a comment earlier about to my provocative comment in the chat about whether online calculators are cheating or not. Of course, it's harder to think about how you might test whether someone can do simple sort of algebraic operations. But nevertheless, there may be ways to do that. But the exams that we'll look at in a moment are probably a little bit beyond that level, and so that's probably not such of an issue. Collaboration and contract cheating, when we do have ways to have sort of deal with that to some extent. We make all of our questions unique, and they're, if students are going to collaborate, they certainly do need to think about how my question is different to this other person's question. And with the contract cheating, well, I think we catch pretty much everyone who posts questions on Chegg, but there's other ways of getting help that are more hidden. Software and online calculators, again, that's a bit like the open book, open internet. I mean, I think we should embrace that and just think about what it is we really want to be testing. We sort of took the attitude that that any basic sort of calculational procedural tasks should be tested during the term. Of course, during the term is online, open book, etc. too. So we have that problem. In the future, we may or may not. But at least in the exam, we sort of just perhaps embrace the idea that software online calculators are fine. I haven't been interrupted by Law yet. I don't know. I'm just wondering whether my sound's off and the internet's gone down and no one's listening.
We can hear you.
Good.
Oh yeah. I'm learning to be quiet. It's a difficult skill.
So yeah, so I guess for our past exams, if we look back, say before 2019, they got a little bit different in 2019 and much more different from 2020. Before that, you probably couldn't, if someone showed you the exam without showing you the year on it, you probably couldn't tell much difference between our exams for the last 20 years before that. Maybe a little bit earlier than that, they were different, bit of a different style, fewer prompts, questions not really broken down into subparts as much. But on the whole, it didn't really matter which year you picked, the exam was the same, everything was always the same. And this sort of led to a bit of a comfort zone for both the students and the academics. And that, you know, that's good for some things. It's good for the procedural skills. It's really bad for the sorts of things that Merrin was talking about yesterday, I think. Certainly lots of students solving problems by looking for cues, and the cue brings out the canned solution that they have no knowledge, no idea of what it means. But it's certainly a much easier way to pass students, and I'm sort of pleased that perhaps that has changed a bit in our recent exams. So the comfort zone tests procedural skills, I think, and more adventurous exams perhaps test whether students have got good mental models, I would hope. But when I say this, and we've produced lots of great exam questions, we've also had plenty of misfires where things were a little bit too complex, or things just didn't work out the way we thought. So probably we would claim that the pandemic allows it's let the students, everyone has forgiven us, I think, because we did this during the pandemic and it was during an emergency, and they understood that something had to be different. So the other aspect of all of this, and I think Laura's going to say more about this in the slides that she's going to look at. Most students are not pure math students, and the maths and stats, and particularly stats, I think Laura should look at, they're tools. And do we do these by hand, or do we use resources and notes, and do we use software? I think everybody does. So if you can incorporate those into exams, that's great. We do. In the past, we were constrained by students sitting at a desk with a pencil and paper exam, and they couldn't use software just because of the restrictions of the environment. It was just that we couldn't provide everyone with the same software. If it's online, we pretty much can provide everyone with well, at least it's the same minimum amount of software, and they should use it. So instead of using a table of normal values, they can just use R or even an online calculator or something. They don't really, that table is not more useful than software. Okay, so I'll just show you quickly some exam questions, and I'll hand over to Laura. I think I've gone over time. I'm not sure what time I'm supposed to finish, actually. I haven't looked at the timetable. Frank, how long do I have?
Normally half an hour, but again, it's the last one, so it eats a little bit in the discussion time. That's not too much of an issue.
Okay. I'm not going to explain too much here, other than this is a bit of a show and tell. So this question here is actually one that could easily have been in an exam before, because there's no technology involved. It's more conceptual. This has been designed to avoid something where we just ask students to calculate some value. So previously they might have used a normal distribution table, or if it was some sort of function like a quadratic, they could do an integral. things like that. But this one uses none of that, and it's probably anyone who's just learnt that they have to do an integral and doesn't know what it means would be completely bamboozled by this. They've got no idea what to do. And we've been running sort of exam review sessions for the next term, and this one generated quite a bit of interest in that. There were students who were they quite liked discussing this one and seeing that actually it was relatively easy if you just had a good mental model. Anyway, I'll flip to the next one. We've also tried to make exams which are essentially ungoogleable. I mean, you can't. This is sort of almost one of the tests in our exam design toolkit. Can you Google something that tells you how to do this problem? Of course, everything you need to know you can find on the internet about Riemann sums and in our course notes, amazingly. Students tend to go to the internet before the course notes in the course, but that's a different problem. But here on the left, you probably need to do a bit of reading to figure out what's going on there, but you can't just, you've got to think about it. On the right, it's a very simple Riemann sum problem, but you really do have to look at the picture and look at the data you're given and use it. And it's not something, I mean, for this particular question, you could design a system perhaps to intelligent system to answer it once you've seen it, but it'd be pretty hard to see this question for the first time, Google something that would tell you the answer. And even if your friend had, there are many variations of this question. I mean, tens of thousands, I think, at least hundreds of thousands probably. And no two students are going to have the same looking graph, the same stationary points in the same intervals and things like that. So this one here is very hard to Google, and you really, all the information you have is in the notes online, but you just have to understand what's going on to be able to figure it out. This is one I chose. I like this one because actually the online system we're using, which is Mobius, lets you plot nice graphs and just design the question exactly as you like. Of course, the input style is a bit constrained, and so that's sort of why we ended up with this multiple selection question. But here, it's a little bit of complicated understanding on the first part to understand that what we've got there is some sort of quadratic expression defining a surface. Once you've figured that out, this is another question where you really do need to have a good mental model, I think, to be able to understand how you might extract the information being asked for from those cross sections. But this question and the previous one are also really good, I think, as questions for past exams, because every time you hit the try a new version button on this, you get a completely different set of plots and different possibilities. So this one actually, I think this has a lot of educative value for future students. And students could do this question in the exam. It's not like no one could answer it. They could do it. This one here I quite like. This was one early one in our set of exam questions. Well, when this was term 2 of 2020, so very soon after the pandemic hit, and we were still sort of finding our way a bit. But I think this is great. This one is due to Sean Gardner, and it presents stuff about complex numbers that all students should know, and things we'd like them to know. For instance, that the roots, these roots are going to be on a circle, evenly spaced, that kind of thing, and it's it was formatted a bit differently in the exam. The students sort of copied and pasted things to condense it, so you can sort of have an overall view of the question. But this question really got students thinking, and I guess this is another good one for as a past exam. I think that's the last thing I wanted to show. I'm not going to dwell on this because we're short on time, and we should let Laura say something about the stats. I think I should. No one else is stopping it.
Okay, so I'll share, but you need to stop sharing.
Do I need to stop sharing?
Yeah, it says you have priority over me for some reason.
Okay.
I cannot share because you're sharing. Okay, so let me share. So finally, you have an image. Too late. I'm sharing. Okay, so I'm still on Jonathan's talk. So in first year, all courses are math except one, which is stats, and I tend to take care of this one a bit more, so it's the same we had before. So just exactly like in math before, we had pen and paper exam, and the only thing the student had is this beautiful tiny calculator they have in the HSC, and it was invigilated. So yes, you can laugh. So you say you were really doing stats with that? Yes, that's what they had. So now it's online. So we have the same testing system, which Jonathan showed you, which is Mobius. And the new thing is that we have R and R Studio, so they can, which are stats software, so they can actually use this during the exam. And same problematic, it's not invigilated, it's open book, in theory, open internet, and in practice, sometimes open friends and open check and contract cheating and everything. It's a bit too open. So it actually made a big difference in the exam. So this is the exam they had before the pandemic. And as you can see, we wanted them to know how to use R, so we teach them that during the term. But then at the end of the term, we had to give them the R outputs because they didn't have R during the exam. And even if you've never done any stats, you look at that and you say, start with P, so we're calculating a probability, and chi-squared, so it's probably a chi-squared test. And there are 2 degrees of freedom. So some sophisticated lecturer would give a little bit more, but even with the second one, even if you know nothing, you don't understand a thing, you know that it's a T distribution because there's this T everywhere. So these output were giving a lot of information, right? And in the first one, probably the 2.41 is an important value. So you're given some data, you need to torture it enough so you get a 2.41, or you did something wrong. So these were really big hits. So as Jonathan explained, and as you all remember, we were basically thrown into this exam in the middle of the term. There were no past exams where the output were not given. So that's actually the first one after COVID hit. And it looked exactly like what they had in the paper exam. We became a little bit more mean the term after that, where we tried to give fewer indications. So now they no longer know if it's a normal distribution, a T distribution, and we give them a bunch of values. But the real goal was for them to use R like in real life. And now that's what it is. The outputs are not given and they need to do it themselves. So it's more authentic. And also, as Jonathan was saying, students are driven by the exam. So being able to use R and decide what they would use in R now seems much more important now that it's included in the final exam. It's not like a thing to play with during the term, but doesn't really matter. So it also changed the way we teach, because now that we're not giving them the R output, we've been adding a lot more R in the slides, the R code. So that's also why we've been slowly increasing what we ask them to do in R in the exam, because at the same time we had to build the slides. And so we've been nice. It's ready to copy and paste. It does exactly that. We say, well, the LMUC means linear model. It will plot this. Now you do that. So we describe, we comment a lot the code, so it's ready to use. So now they have no excuse for not knowing how to add, for example, a line of best fit to a scatter plot. And so one new thing also, now they have R, we can ask new types of question. When you do some stats, it's good to be able to do some simulation. So 2 types of simulation, some to answer some theoretical question, and that's an example there. And you could also have some random variable, which is a sum of 2 others, or a mix of 2 others. And in the end, it creates a new random variable for which the distribution is not one of the well-known ones. But with simulation, you can actually calculate probability for that random variable, although you don't know the distribution. So we try to amaze them with that also. So in that case, as usual, and that's also what we do in maths, and Jonathan didn't mention, a good start from exam question is what the students do wrong. So this one is built around the idea that people are wondering if the expected value of x squared is just going to be the square of the expected value. So there's a story, a student believe it is, and the other one thinks it's not. So what we do is generate some values and then calculate the expected value of the result. It's not very hard. You just need to do simulation. And in case you wonder how the story ends, in that case, we explain to them and we really guide them closely with the theory to say what the expected value of x squared would be. As you can see, if you've done some stats, we're giving all the formulas. So these things are not hard. So if you accept to read and you just follow the flow and you try to understand what's happening. You can't do it from memory. So we wanted something that was new, that needed understanding, that was not recognizing a pattern, but didn't necessarily it didn't have to be hard. I think this one's not hard, actually. And the result is, so we gave students all these tools. We're starting getting answers we did not really expect. So for example, that's the exam which took place last week or so. And the lecturer is in oceanography. So that was real data. And in the real data, we wanted to find the line of best fit and to see if it was possible to predict the duration of the heat waves from their intensity, and would you recommend? And what they had in mind is all the data were numbers between, let's say, 10 and 20. And then we were asking them, can you do a prediction for this really small number? And she wanted them to say it's extrapolation, so no. But what happened is the student just took on board everything we had taught them. So they had all these tools. So some of them actually drew the scatter plot and say, well, it's not really linear. It would be stupid to do predictions using a linear model in something that's not linear. Yeah. We also got, well, there are really some outliers in my data. And I know that the outlier can totally change the coefficient of this line of best fit. So I would not recommend doing that. And now, because they had all these tools, they're starting giving answers which were not the one we expected, which was extrapolation. But actually, it's what we would like them to do in real life. They have the data set and they wonder if they can do the prediction. So in that case, it was no, no, and no for a lot of different reasons. But exploring all of that was a good thing. So we're actually happy. Another thing is, because every student has a unique data set, so we can identify them after the fact, it means we had to go back in the question and put some feedback for the markers, so they would actually see the graph, so they could see if it was really not linear and if there were really some outliers. So some surprises for us too. But I like the fact that the students were thinking and using the tools at their disposal. So there was this debate in stat, much more than in math, because in math, Jonathan just said, we're releasing the past exam, and that was it. In first year stat, there's the stats department involved and many more people. So for long, we didn't release even the paper exam, and we didn't release the past online exams. And because the idea was that it was so hard to create things that were different, which is also true. But then there was really this argument that some students are building database from our old exams and others. So some students will have and others won't. So we ended up releasing them. And actually that has led to more creative exam. We really had to come up with new questions every time. What Jonathan didn't really mention, this has really, the level of work involved has exploded, because when people thought that it was safe to reuse a past exam, they would just change a bit the story. The exams were all the same, and it was really taking much less time. Now, not only we need to come up with new ideas, and it's not that easy, and then you need to randomize everything. So students, so we can identify the students, but there was a payoff. And again, I'm going to plagiarize Jonathan. Our exams become past exam, and our students are really interested in our past exam. And I think they learn a lot from working on those. You can see the forum explode with question. They're really thinking. And if you design the exam well, sometimes we design question mostly in the thought it's really something we want for the future, for our future students to think about. So it was worth it. And indeed, I agree with Jonathan, our exams are better than they used to be. So thank you for listening, and sorry for